Okay, thank you for coming to the basement room. My name is Bruno Borges. I work at Microsoft. And today, this session is about serverless computing and enterprise integration patterns, just to get an idea how many of you use or apply enterprise integration patterns. Okay, awesome, most of you. Who uses Camel? All right, most of you. All right, cool, well done. I used to work before I joined Oracle, actually, 2015. One of the last production systems that I architected myself with the development team was using Camel to deliver content for subscribers for a telco company, and we would use Camel basically to get a subscription list and send that over SMS to millions of mobile users. And we used Camel with ActiveMQ deployed on JBoss, and it was quite an interesting architecture that we did because there was a lot of dynamic routing that we would need to change over time based on new channels that the marketing team, the content team would produce. So the Camel infrastructure would have to be always live, always up, but we needed the ability to deploy new routes, new content type to the flow to deliver that message. And we were able to design that with Camel, ActiveMQ, some JBoss module system for dynamic redeployment and so on. So it was quite a good experience. And at Microsoft, I joined this year, and I felt like, okay, this serverless thing might be interesting. And I remember of this project I did in 2015, I thought serverless actually might have a role in enterprise integration patterns. And this talk is about my personal research on this area and how we might be able to combine serverless and why with Apache Camel mostly, but you might also want to use some other frameworks like Spring integration if you want. So just a quick recap on serverless. I'll just provide some points. I do like to summarize how I understand what serverless is and why. I know you guys have heard about several times what is serverless. I just have 3 points that might make it more easy to understand on an integration context. Then we look into enterprise integration patterns, and then we try to combine them as part of this talk. So what is serverless? Abstraction of servers. We don't want to pay for servers. We don't want to pay for infrastructure. We just want to pay for what we use. Event-driven. As you know, enterprise integration patterns, asynchronous messages, it's all about messaging and events. So serverless is also mostly designed for event-driven applications, whether that event is a JMS message, whether that event is some data that popped up in a database, or some object that appeared on a storage container, or most basic example, HTTP request, which is some sort of message, asynchronous message, that does require a response, but it's a message regardless. And most important, microbilling, you want to pay only for the things that you use. So in short, infrastructure abstraction, you don't care about the code, the infrastructure code, you don't care about setting up things. It's function as a service, so you pay for the functions. You pay for the usage and invocation of functions. And it's serverless-based applications all triggered by events. Most common event is HTTP. It's most common, the easiest way to understand is HTTP events, but actually it's one of the least interesting event triggers. I think the most interesting event trigger might be some messaging system, like a Kafka streaming or a JMS system. To understand where and why we are here today in the serverless world, I made this section where we think about hardware, where in the old days we would actually buy a server. We would go to Dell.com, HP.com, Lenovo.com, whatever hardware company, actually buy the hardware, ship to the data center or our own data center, the company's own data center, and would set it up in order to have a server. But basically we have no life if we do that, because we even give a name to the server. It's our little pet. It's like, server C3PO is out. Oh my God. So you do have a lot of concerns and care for this server. And then eventually you figured, we have too many servers. We have too many, this Excel spreadsheet is huge. We have so many servers, so many IP addresses, so many usernames and passwords that we have to manage. And then somebody adds a new server, they have to update the spreadsheet and share over email with other system admins, and then you just start losing control of that environment. So then it came in virtualization. Not only it reduces the concerns of managing the hardware, but it also the speed to provision these environments. The hardware is already there. You just go to some console, maybe VMware, vSphere. You just set up a new VM, and there you go. Just because you just want an SSH access, you just want an operating system, maybe Linux, maybe Windows. All you want is to get into that server and use it. But still, these servers have names. They have IP addresses. You still know them. And then it came containerization. Now, everything is a container because you figured that, I'm spending too much time setting up my operating system. I have to install HTTPD. I have to configure IP tables. And who wants to configure IP tables? No one. Okay, good. So we are evolving. All you want is to deploy an application that has all the dependencies, binaries, libraries, native libraries, all contained inside a container. And all you have to do is just expose the port. But you still have to set up some orchestration framework, and then you have Kubernetes and so on. And then next level is you don't care anymore. You don't care about infrastructure at all. All you want is, here's my piece of code, and I want to process this event. Whether this event is an HTTP trigger, it's a Kafka message, it's a database trigger, whatever. And based on that, you think, that's why serverless is interesting, because it abstracts so much that I don't care about anything else, because I don't give a damn anymore. That's the purpose of serverless. So you don't care about setting up an infrastructure. All you want is expose a REST API, process a message in the queue, or get some storage object and process that information and send the calculated information to somewhere else. So how can we go serverless? What are the options? There are a couple options. If you want to cook your own serverless environment, and I like to say that there are reasons why you should think about running your own serverless environment on your own data center. But Bruno, I have to set up my infrastructure again. Well, someone will have to do that, but it will have to do it once. The developers will not have to care. All they will do is provide the function, and that will run on your on-premise environment. So this is one way to think. So for cooking your own function as a service environment on your data center or in the cloud, if you do have your own cloud provider, you can use Apache OpenWhisk that is provided, mostly maintained by IBM, FaaS that is sponsored today by VMware, FN Project by Oracle, Project Riff by Pivotal, and Kubeless that I'm still not so sure who owns that project, but I think it's a mix of Google, Microsoft, and other companies. But then you feel like, okay, no, I'm a sysadmin. I don't want to care about that. I'll just pay the bill. I'll just use some cloud vendor that actually provides that to me, for me. So you do have options. The obvious one everybody knows, AWS Lambda. It's already there. Azure Functions from Microsoft. Google Cloud Functions, IBM Cloud Functions, and the one that's coming soon is Pivotal Function Service, which is based on Project Riff. So these are just some options that you might want to evaluate if you think, nope, I like the idea of a FaaS, but I don't want to run it on my own data center. I just want to use a cloud provider. Or, no, I want to use this open source function service environment, and I want to deploy, so I will offer a serverless deployment model to my developers in my company. So you can consider these options. And again, serverless code execution not only on Azure but on other places. It's all event based. So most common again, HTTP requests. Some of them offer a cron job, a scheduler, a storage change, IoT event, Twitter. Twitter might be a source of events. I don't know. it's an option. So just to give you an idea of what serverless looks like in the cloud, I'll just create a quick application. So let's say I want to create a hello world for Azure. So I'll go here and I'll just generate the latest version, not 10.11. So what this will do is just, ask me for some information about my project, and there is nothing that you guys are looking at, right? Yeah, there you go. All right, so here we are. I just started Maven archetype generate, which is like a scaffolding thing for. So DevOps, Azure Func, version 1. Package is DevOps. The Azure Func will be DevOps Func, actually. Data center will be West to West. Resource group, default, and all good. So I'm going to go now into my Azure Func. Oops. Here. And I'm going to create this function. So what this project does is it's a Maven project that has the Azure Functions Maven dependency and the Azure Functions Maven plugin. What it does, it will generate the whole package for this function to run locally. And the way it runs locally is already installed the Azure CLI and the Azure Functions tools, which is the runtime of Azure Functions for local development. So when I do Maven Azure Functions, the Maven plugin will start that runtime and will provide me with a REST endpoint that says hello. So what I'm going to do here is go to my browser, say hello, and it will complain because I didn't provide a body or a query string. So I'm going to say name equals DevOps. So hello DevOps. Now this code, I also want to deploy this. So all I'm going to do is just Azure deploy. Now, because this is a Java function, there's the JVM, there's a code startup time that is inevitable for now. So it might take some time for the Azure function to start when it's accessed for the very first time. So because of that, what I'm going to do is I'll trigger the call, and then I'll show you the source code meanwhile. So we save time, we optimize our time. So let me get to the Azure Function project and open VS Code. Okay. So here we are. This is the source code of that particular Maven project that was created. And what I do have is a function class with a hello name. So this project is created using the HTTP trigger, which is the most simple way to get started. It defines an HTTP trigger, provides a name, and which methods this call supports. So it only get and post. And it gets the parameter name, which I pass as a query string, or the body of the call if it's a post call. And then returns a hello name with a 200 response. So this is basically what a function in Java looks like. These annotations do generate a JSON file that has all the actual configuration for this function, and you can use either annotations or generate or manually write the JSON file if you want. This is. The other ones are very. Other projects are very similar. So FN project, you create a Java class that has a method and a string as the input, and the method just returns a string. So you got input and output. And inside you just use whatever you want. Yeah, and then you deploy. So FN project from Oracle will wrap your Java application within a Docker container that is designed for the FN project, and then use your Java code as the business logic processing unit of that input.
When I use Azure, then I have to follow.
If you use Azure, you have to use this SDK. So there is one way that you can abstract this. Pivotal has an interesting project called Spring Cloud Function that abstracts the development of serverless functions. and they have adapters for Azure functions, for Amazon Lambda, and for Google Cloud Functions. So that's a way that you can rely on Spring code, but be able to deploy to different clouds. But this code might not be deployable on FN project, though, because they have different ways of treating the input and the output. So there are many ways that you can avoid specific lock-in to a specific cloud, but then you also have to consider the trade-off of losing functionality from this cloud if I abstract too much. So you always have to consider your options. Okay, so my function was deployed. This is the URL. Again, it takes some time to start. I'll just leave it here to start it for the first time. And meanwhile, we'll go back at the source code and just look at it a little bit more. So when we look at the target of this function, the most important thing is this is a Maven project. So you can actually add any dependency, any Java dependency. If you want to use Lombok, just add the Maven dependency. All the Maven dependencies will be wrapped into a zip file, and this project will run on Azure as a normal Java application. So all the libraries that you extend will be there. So this is what it actually generates. This is the actual JSON file for this particular function. And this particular function is not this Maven project, it's actually that method. Because I can have one Maven project with several classes and several methods annotated with the function name, this annotation over here. So I have some level of granularity and grouping. I can have what is called a function application that might have multiple functions. So for this function, the script file, which is the jar file, where you're going to find that, and the entry point is this particular method in this particular class in this particular package. And then what binding will be used to trigger that method. That will be the HTTP trigger with the direction it's input and the methods it's get and post. If I want delete, I can either come here and say delete, or I can go to my annotation and use the annotation. You just have to consider whether you want to use generated JSON or manually written JSON. And that depends on how you configure your Maven project. Okay, so the application is up and running, and what I can see here now is API/hello, and the name will be DevOps. So the environment is up and running, and my function is now live with this Java application up and running. Now, as most serverless platforms, there will be a timeout. If there's no more calls to this serverless function, the instance will die, and then the next call might take a while because there is a cold startup again. And all of this is because it saves resources in the cloud environment, and you only pay for the actual invocation of these functions. Okay, so any questions regarding serverless? No? Okay, sounds good. Now, let's take a look at integration. When this world of functions started, there was this notion of breaking down a monolithic application into microservices application, and then some person crazy said, microservices is not too granular, let's make it even more granular. And then they decided, let's have hundreds of functions instead because it's so easy to manage, right? The problem is with the more integration points that you have in an application, the higher will be the complexity of that system. It's simple logic in this case. So just using code as the glue between these integration points is not very smart, because now you have a function that has hard-coded the name of the other function that will call this other function that will call this other function, and suddenly you have a mess, and you cannot easily reuse functions because one function depends on another. So that's why we might use enterprise integration patterns. So we have these endpoints, and we can easily integrate them and even apply patterns that will treat the message, the payloads that are navigating between these entry points. So who's familiarized with if this then that here? All right, many folks. Okay. So if this and that is a very interesting service. Basically, I call it enterprise integration patterns for your parents. It's like they might go to this website and say, if I get an email with attachment, please move these files to Dropbox. So you kind of apply this they kind of apply enterprise integration patterns right there. The actual enterprise integration patterns are in this book that many of you are familiarized already. If you're not, go to this website, aka.ms/EIP book, to check it out on Amazon, and I suggest you buy it, but I don't suggest you read it from end to end, because it's a waste of time. But take a look at the glossary, look at the patterns that exist, and read the things that you feel like interested about, and always take a look at it when you do have an integration problem, and you might find the perfect solution for it in this book. One of the best frameworks that implement these patterns is, as many of you know, Apache Camel. So the website, you can go to aka.ms/camel. It actually takes you to camel.apache.org. It has many of these enterprise integration patterns implemented. It also supports DSLs in Java, in Scala, XML, and Kotlin, and hundreds of components. And I think the biggest value of Camel is not in implementing the integration patterns, is implementing the components that you can use to connect to systems. And systems can be FTP servers, email servers, HTTP endpoints, and so on, and databases and so on. So just to recap a little bit, when you have an integration pattern, this is how it kind of looks like in the book when you read it. It shows a basic pattern of messages coming in, and then you apply a filter that has a business logic that will separate the good messages that you want and throw away the bad messages that you don't need. Here the example is I'm receiving 6 images of raccoons, and I only want the low resolution images. So I apply this filter. In Camel, this implementation is with this Java code. The implementation using XML and Kotlin DSL is very similar, and Scala DSL is very similar. But in the Java code, I like it because it's very descriptive. So from some endpoint, and I will apply a filter, and I will look at the header of this message, this payload. And if the resolution is low, I will accept. Otherwise, everything else will be thrown away. So, quick trivia. What is the name of this pattern? Shout out very loud if you know. Splitter. Okay. Very done. Well done. So in Camel, to implement a splitter, which means getting one single message and breaking it down into units of work, into 3 different messages in this case, what I do is I just apply a split. So from a specific endpoint, I'm going to split the body of my payload, my exchange. And the split method on Camel will basically look at the data type. If it's an array, it will take each element of that array as a single message from now on. If it's a list, same thing. If it's a set, same thing. If it's a hash map, it will be a map entry, and so on. It does support splitting other types of payloads. Let's say it's a JSON file. You can split the content of your JSON file based on a JSON path expression. A JSON path expression is similar to an XML XPath expression. And it also supports XML in a similar way. So just to learn a little bit about Camel, for those who are not familiarized with it, but for those who are, it's an actually interesting demo. So stick with me on this one. So this demo, the most interesting thing about this demo is actually this demo was built initially in 2012. It was tweaked. It was originally written by one of the Camel developers. I got that demo in 2013 from my Java 1 presentation. I tweaked it. And then I got it again this year, and I didn't change much, and it still works. So that shows how much stable the project is. That shows how much Maven still works, how much the Java still works, and I mean, frankly, even JavaScript that is used in this project. So let's go to work, EIP, Camel, Twitter, and just call Maven. So what this project will do is there is a route that connects to Twitter and starts reading tweets over the streaming API, and it's looking for the hashtag World Cup because it's happening. World Cup is happening right now, and here we are. Okay, so let's look at this page. So what this project does is it looks. Let me just start an incognito window. Yeah, this is better. So it looks into Twitter messages, and Brazil's playing. No, it's not. Okay. So it just looks into Twitter, streaming API, search for tweets with the hashtag World Cup, and at each tweet that it finds, it will extract the image and then send over a WebSocket to this web application. All of that is done with Camel, and it's very simple. The amount of code, it's mostly Camel code, reusing all these components that Camel already has. So let's take a look at this source code. And I need to clean this code. See? So what happens here is that because I'm throttling the tweets, it gets so many tweets in the queue, so sometimes it takes a while to shut it down. So that's why I usually have my kill all -9 Java. Always comes very handy. Okay, didn't need to do that now, so let's take a look at the code. Okay, here, actually, that was the class that I wanted to show. So here, I got my Java class with a quite weird route, but it actually, they have lots of purposes. So here, all starts with the Twitter component, streaming API, and I'm going to filter on a keyword that I set on an application resources file. And then, for every tweet that the streaming API sends to me, I'm going to send to this route over here. So it's set images, there you are. And I'm going to process this, so it's a exchange processor. And I'm going to extract the image, meaning I'm going to look at the tweet object, and I'm going to look at the media entities. If there are media entities, images on that tweet with that hashtag, I'm going to extract the first image because I only care about the first image of that tweet. So back to here, if I click here, this is a tweet that might or might not have multiple images. I don't care. I only want the first one. So back to my code, I only got the first index. And then I convert this this status object, which is my payload, from Twitter4j library, quite interesting Java library for Twitter. And I convert these into a tweet object that is my class, just with the name, with the text, and the URL of the image, which is basically these 3 elements that I have: the username, the text, and the image URL, which the browser will load for me. And then I sent this as the body of the inbound message of this exchange, of this payload. Next, I'm going to extract some statistics, so basically the count of tweets. And the statistics, they appear over here at the top. Until now, we got 700 tweets and 237 images. This content is provided to the application through WebSocket. And I'll see if I can show you that if there is time. Next, I'm going to filter. So if the body is instance of tweet and not status from Twitter4j, then I will proceed with that. If it's a status object from Twitter4j, I will ignore, because I don't want those objects. I only want the tweets, because those are the ones that have images. And I'm going to throttle. Why throttling? Because I don't want to show 200 tweets per second. It's pointless. I will not see what's going on, and the browser will probably kill my memory on my laptop, and it's Chrome, so you don't want that. So what I do is I throttle to up to 4 messages per second on this route, on this processing. And I want to cache this to ignore some repeated stuff. If that's the case, I want to marshal this into a JSON object, and then I'm going to convert this into a string, because this will be sent over WebSocket. And then finally, there you go, to WebSocket, and that sends to the images endpoint on my WebSocket application. All of this is loaded then later over this JavaScript code here that I have my var app images, and I start reading on the WebSocket endpoint, the URL, and here's the endpoint, tds1camel/images. That's the same endpoint that I'm sending from Camel. So I start a new WebSocket, and for every on message, I call the on message. And if there is data, I will call the JavaScript function gallery and data. So the JSON object will be here with the information about that tweet. And what gallery will do is just set up the image object and the div for setting this image on this web page. So let's just skip that part. Okay, so I do have a cron job. So I will, for every second, I will send a WebSocket message to my web page with statistics. and it's basically the message that is over there. And again, simple process that sends over WebSocket and converts to JSON. And most of the rest of this stuff here is just some tricky things that I did that you can go to the console in Chrome and call some functions, and you can update the search term. Anyways, so let's get back to our slides here. Okay, so you got your understanding of Camel, how it runs, how you can use. There are many patterns that you can apply. I mean, we didn't see the most interesting ones. Basically, I showed you routing, message, filter, throttling, and some basic components that are part of the infrastructure, which is Exchange. Exchange by itself is a pattern. Channel is a pattern, and so on. And once you learn these patterns, you can find the easiest solution for your problems. And just for you guys to have an understanding, the most common used component in Camel is FTP. The second most used one is file, because that's how the world works. Systems that are very old, they work based on files, CSV files, record files, whatever. And then we Java developers, we got this request, hey, we need to send this file to this FTP on this other bank to upload some transactions to them. Yeah, Camel, it's perfect for that solution. It scales. So it is quite interesting to see how many components Camel has, but still 80% of the use cases use 20% of the components. Some ideas where we can find EIPs and serverless being used together and why. I think actually I'll skip this slide because I just built some slides that explain that better. There are other solutions for integration. Camel is, in my opinion, the best. You also have Spring integration, but then we have the corporate, more vendor approach. Where you have MuleSoft, BizTalk from Microsoft, Oracle, SolarSuite, IBM has one, Typical, and so on. And then we have these cloud integration options. So Microsoft has this service called Azure Logic Apps, where you can go on the browser and design a flow where you can set, okay, here's my entry point, it will pull message from this place, and then it will process. And then there is this component that says serverless function, because I want to process some sort of payload. And that's the part I'm most interested about here with Camel as well. So let's put some pieces together on this architecture. So when you think about Camel being part of and using serverless functions, you can have your Camel context, your Camel application always running, hopefully inside a container, so it's easy to deploy and redeploy and so on, and also scale if that's the case. But your Camel context is running over there. It's always running, but there are some parts of your processing that you want to have the ability to change the business logic or add some logic without shutting down Camel or rebooting Camel. So those endpoints can be functions. The entry points can be serverless functions. All the routing and the processing might happen inside Camel, but when you have an HTTP message that comes from a serverless function and that is sent over to Camel, that has the routing process. Or you have events that coming from Kafka streaming or database also send a message to these other functions. And at the end of this Camel context, you can have a message that is sent to another serverless function that will know how to deal with that message and where exactly to send and store that message. And then again, you have your Camel context with your routing process, very defined, but pieces that are more dynamic, that you feel like this thing might change in the future, that you expose as a serverless function. So it's a good approach of having a stable environment that will always run, will always be running, but it's easily extensible and easy to customize. You can go one extra step and actually run functions within the execution of your Camel route. So you have to this endpoint, to this endpoint, to this endpoint, and then to this endpoint is actually a serverless function that you return some payload a converted payload perhaps, and will continue your routing, your message routing within your Camel context. One good example, perhaps the best, is this serverless function might be implementing a dynamic content-based routing. So let's imagine you're getting JSON payloads that have a type of document, and these documents are stored on the database. And then your business user said, okay, we need a new type. And then you don't have to change Camel. You don't have to redeploy Camel. You only go to that particular function and you add that logic. If the type is X, the new type, now you're going to send this to QX. And Camel will process that message dynamically. So that is the sort of interesting approach that you can have. And you redeploy that serverless function, and the Camel is still running with all the other payloads that are still there. And the third, perhaps most crazy approach is to run Camel as a serverless function. You can actually start Camel inside a serverless function. As I told you, the Azure Functions works with Java projects or regular Java projects. So you can run any dependency, any Maven dependency. Camel itself is a Maven dependency. So you can go into your serverless function, function name hello, you can go new default Camel context. And then you start running Camel inside that. Now, there is a catch with this approach. In this case, the Camel context will not always be running because there is the cold startup, as I said before. Your function might stop because of timeout. So the instance is removed, and then if there is an event later, it will start your function again. You will create the Camel context and start processing and so on. So that might take some time, and all you actually want is to process really fast. So this is part of a conversation with Red Hat, with the developers of Camel, and we discussed this at a previous conference, and there is an interest to make Camel more lightweight. And if you guys are interested in this approach, I expect you to share that interest and that feedback to the Camel developers to have this more lightweight version of Camel where you can still reuse several components that are available, but it doesn't cost too much to start Camel and process and exchange. So let me show you a bit of this approach of combining serverless and Camel. So it's Camel Azure Functions demo. And I'm going to open this code so we can see it. And I'm going to start. Oh, sorry. OK. So I just opened Visual Studio Code on this project so we can see it. OK, so Maven. Now, because I prefer to run these functions locally because it's just better for demo purposes, so I hope you guys don't mind. The Azure Functions deploy works fine, but if I want to shut it down and start over again, make some changes, it's just easier. And plus, the internet is not always reliable, so let's just stick with that. So Maven Azure Functions run. Okay. And it started. Now, this project, this function application has 4 functions. Each function has its own endpoint. Now, one of them is extremely stupid. It's a function that will turn text into uppercase. It's a very complex demo. It takes time, so let's bear with me. So this demo, I'll just do upper, and I think code equals Bruno. Maybe not. Let me look at the, oh, it's body. So let's do this. Yeah, there you go. So here I have this text file on Visual Studio Code that, that I can write some HTTP calls, and it just gives me a nice UI, so I can just call here, and I can change the text to whatever, and I can just say, Poland, and send request, and it turns to uppercase. But this upper to uppercase, it goes through Camel. So it's not just a 2 uppercase. 2 uppercase is too easy. You have to make it very hard, very complex. So let's look at that code. Now, let me close this. Here I have a route that says to uppercase. I'll log it because it's important to log, and I'm going to set the output body of this exchange to be the input body of this exchange to uppercase. Now, how is this invoked? From the function name upper, I get my HTTP trigger, I get the body, I create an exchange on the Camel API, I use a producer to send that exchange to that particular endpoint to uppercase. I have an out exchange, the return of that call, to a string, and then I send back as a HTTP 200 response to my HTTP call. So that's why this returns an uppercase. Now, super stupid, don't do this, but it's quite interesting to see just a proof of concept. This was my first proof of concept starting Camel within Azure Functions. And where the Camel context is created, it's created in the constructor of this class. So here's all the route definition and then Camel context stored. Okay, so let's do a more interesting example. So let's say you want to use a serverless function to split the payload, and you have some dynamic logic that the payload might change, and the pattern for splitting that message might change. But you don't want to change Camel, your Camel application. So there is this message splitter here that will get a payload. For example, this JSON file with an array of codes that I want to be processed. But I want these codes to be sent as unit of work to a Kafka stream. And the destination is set as a header of my call. And that will be, interestingly enough, another serverless function. And the split pattern is a JSON path that will be used by Camel dynamically. So what I do now is just send request, and it was processed. And if I look at the console, I can see here each code being showed by my application. So all of these codes were processed individually. So let's see if I can just call this again with different codes. Don't save. Oh, here. So ABC, foo, bar, beer, wine. And let's call it again. Okay. So there's foo. So it is processing, but the reason the request, the HTTP call process fast because I don't care. Everything else happens in parallel, asynchronous. So I don't care about that. So I get my HTTP response. And what I do care is that these messages will end up on a Kafka queue. So let's take a look at this serverless function to understand where these messages are going to. So message splitter will get the body, and we'll create an exchange to that Camel context. Here's the body. And it will add into the Camel exchange all the headers that I got from my HTTP request. So all that information from split pattern, destination method will come from here. So this is what injects them. And then it will send to message splitter. Message splitter is defined over here at the top. I will convert that into a string, and I will look at the content type. Again, the content type is a header on this call. Here it is. If the content type is application JSON, I'm going to send this to JSON splitter. The JSON splitter will split using a JSON path that came from the header of that message. And after that, I'm going to stream and process in parallel each message that was splitted, and I'm going to send that to dispatch. Dispatch is what it will look into the header of destination and destination method and do the REST call to this other endpoint in the future. And the endpoint that we will call is the Kafka one, which is defined here. So this is another serverless function that will queue on Kafka. It gets the payload. If there's no body, it says missing value. builds the exchange and sends to queue on Kafka. And queue on Kafka processes this, the body here, converts to a string, process exchange, sets the header partition key and the key, just a random int, I don't care, and we'll send this to the queue messages in my Kafka server that was configured above here. So all this logic makes these entry points, these endpoints, very reusable, and I can combine my serverless functions, and I can even replace the serverless functions externally. I can externalize these functions into a different class, different project, and I can change them over time if I want. And with that, we have this dynamic route. Oh, here it is. It processed now. All these messages that were, here this last one. So it's still processing. So this is the sort of possibilities of combining Camel and why you might want to combine. If you feel like you need something even more dynamic that you want to externalize to a serverless function and then redeploy that over time without necessarily changing your Camel application. And you can do some weird things over here. So Storage Explorer is Microsoft Azure Storage Explorer, so I can look into Kafka to see these messages coming through. So I can go into my storage. It's running on this one here, NATO, rollup containers, Kafka messages. So I go to my Event Hub messages, 2018, June 21st, today. And now, yeah, this is running on US time zone, so that's why it says 15. It's on the US data center, so 3 p.m. and 49, and it's still processing these messages. So here it was created 5:59:51, so it was like a couple, maybe 10 minutes ago when I did my execution background. So these messages are coming through, and they're still being created over this background. So how did I do this Kafka thing? And how does the function looks like on the Azure Functions portal? So let's take a look at that. So here in the portal, my function is deployed as a function application. So let's look at the NATO for me. This is the function that devops function that I just deployed today, like right now in this session. So here's the function. It only has one function. This is the function app, which was my Java application deployed. And it only has one method with that annotation function name. So that's why it only shows one function. And I can do some settings. I can remove this function, shut down this function, and so on. And I can even execute this function from here, from the dashboard, and we'll just do an HTTP call to that. And the Event Hub was configured from here. Just came here and add. Then I created this Event Hub, and I created a unit. So the unit is called messages. So that's why it's Kafka messages on my endpoint. And the thing that enabled me to look at the Storage Explorer to see those messages, those actual messages, is this feature, this capability called capture. So all I had to do is capture all these messages that are coming through Kafka and send that to the Azure Storage Kafka messages. So that's why on the Azure Explorer, a Storage Explorer could see those objects. So that's why I prefer this. If you do want to use Kafka, full-fledged Kafka, there's another service called HD Insights that runs Kafka full-fledged. The Event Hub exposes a Kafka API. And the Camel component works just fine because Camel component for Kafka uses the Kafka protocol. And this service supports that protocol. So that's easy. So to wrap it up, if you feel like, no, I don't want to write code, there is this logic app, and some other clouds have something similar. It's like if this and that, but for enterprise use cases. So they come with several components. You can just go there, select a component, Dropbox files, database, whatever, and the message will come in. And then you can add a serverless function in the middle to process it. It will be most likely a JavaScript function by default, but you might be able to change that to another type of programming language or create a function then add as a REST call. And finally, if you do want to take a look at Azure Functions in details and logic apps, and the third URL here to me is the most important one, because all these cloud patterns for building cloud-based solutions, integration, messaging, scalability, and so on, these patterns are designed in our documentation site, but they are actually applicable to any cloud. So I highly recommend that you guys take a look. And with that, I say thank you so much. Anybody has questions? No questions? What? How we handle state? So serverless functions is not stateful, but there is a functionality called durable functions that is being implemented initially for C# functions, and it's being under development for Java-based functions. Durable functions will provide the state that you're looking for between calls.
You said when it was talked about the camel inside the function, the crazy scenario, the heavy one, and it takes time to wake up the function. But what about the normal case?
No, so if you go with these scenarios here, for example, this one, your Camel application will be running as a normal Java, like Spring Boot, right? It's Java minus jar, my Camel application, and then you run inside a container or inside a VM, anywhere, and it's an always running application. So I prefer this approach because I have no doubt that it will always be there, and there's no cold startup. So I prefer this approach. Yes, it's on, it will be, this is an updated deck, so I will update tonight on slideshare.net/Bruno Borges. You can find the previous version that does not include these 3 slides, these 3 architecture slides, they're not there. But I will update tonight and
where can I find the link?
It's, so slideshare.net/Bruno Borges. Let me make it easier for you guys. Oops, slideshare.net/Bruno Borges. Yeah. Sorry. Yeah, this is the URL where. This is where you can find the previous version of this deck that does not include these 3 architecture slides, but I will update, and what you can do is just wait 24 hours. Yeah, cool. All right, any more questions? No? All right. Oh, more questions over there. How many requests? Oh, many. What it will do is it will instantiate and then call either the same instance multiple times, or it will scale based on demand. There is no documented number on how many it can handle. But if you want to run a benchmark and share with us, we would love it to know your findings. There is no. So what we do provide is if you create an Azure function on the free tier plan, you get 1 million invocations per month for free. After that, you start paying, and it's every month. Now, how many invocations you can handle per second, that we don't have documented yet. So it's more like per use case. It really depends on what you're doing inside your function, how long it takes for your function to start. So this one starts Camel. So Camel takes a while to start, so it depends. Mm-hmm. Oh, it will just scale. It will just create more instances to handle these requests. Yeah, it scales on demand. And I do recommend to use authentication, so somebody will not like run your function 2 million times, and then you're going to have to pay for that. So yeah, it's good to use authentication. Yeah, for authentication of Azure function on HTTP trigger in Java, you set the authentication level over here in the annotation. So in this case, it's anonymous, but there is a an option called function key that you have to, the request, HTTP request has to come with a header that has the hash, the authentication hash of this call. It's like an API key to be able to call that. So that's what you would use on an actual production system. And there's another one that's called admin. Don't do that. Not for demo. Or else you're going to be sharing your key, and it's not cool. Other question over there? I'm sorry, can you just speak a little bit louder? So serverless platforms today are only available as a service that you can pay on Azure, on AWS, on Google Cloud, and I think IBM Cloud. Oracle is still working on a function service based on the FN project that you might want to take a look, but they still don't provide a service offering. In terms of general cloud, I would say, yeah, go with Azure, but frankly, you have to evaluate and consider which products you have today. So, for example, if you are an Oracle customer and you have many Oracle products, I would say, please evaluate first Oracle Cloud for that. But you could also evaluate other solutions. Amazon has several solutions that are compatible with Oracle products. Azure has services that are compatible. So we have MySQL Server managed by Azure. You can also take a look at that. So it really depends. So I cannot tell you which is the best. It really depends on the customer and which technology they have. Maybe contracts they already have with these vendors. So it really depends. Okay? Any more questions? No? Okay, thanks again, and thanks for staying. Appreciate it.